We're Group 30 for ME 4010. I'm Jackson.
And I'm Michael Ferguson. Today we'll be showing you how to use and assemble our wind tunnel. In addition, we'll be showing you how to use 3 experiments which are easily adapted for a classroom experience.
Here we have our feet, test section, our fan, and over here we have our nozzle. So first, we want to separate the feet so that they're able to actually support the test section. Then, we want to take the test section and place it onto the supports.
Next, we'll take our contraction section. As you can see, there are Velcro strips on this side of the contraction section, as well as on the end of the test section. So, with the help of a fellow adult, you will then push the contraction section directly up against the testing section, and they should bond together rather easily.
We're going to test the fan. Now the fan also has Velcro along the left, top, and right sides. And Michael is going to attach the fan to the contraction via these Velcro strips along the sides.
And quite simply, to be plugged in.
So our first experiment involves drag forces and how they're affected by changing surface areas. In front of me, you can see we have 3 different sails, each of which are gridded off with square by square inches. Now the students are going to find the total surface area of each sail by counting the total number of squares present on each sail. Then, this track, which has Velcro along the bottom, will be placed on the corresponding Velcro strips inside the test section, as such. Next, the sail which is desired to be tested has Velcro along the back, as does this mast. Now the sail is going to be attached to the mast via Velcro. Then it will be loaded into the test section and pushed all the way back to the starting position. Now the track has been marked off in inch increments so they can find the total displacement of the mast. Next, we're going to come over here and turn the wind tunnel on. Now there are 3 speeds to this wind tunnel, a high, medium, and low. The first speed we're going to test is going to be high. Timer starts. Timer stops.
For our next experiment, we will be investigating how interference geometries affect flow patterns. So, for the demonstration we'll be presenting, take the square interference plate and place it on the front of the pegboard. Next, place the pegboard within the wind tunnel test section, aligning the Velcro strips as in the last experiment. The next step will be to take our flow indicator and move it at various points along the pegboard once the fan is turned on. For starters, we'll place the flow indicator towards the front of the pegboard, closest to the blocking board. Again, while there are 3 fan speeds that can possibly be used, the one we'll be using for this demonstration is the highest setting, or 3. Now, once the fan is turned on, you should be able to see that the tail end of the indicator will move in certain directions. So, as I move this indicator, different points along the pegboard, you will see the tail end flows differently. These are observable differences which can be related to scientific concepts that will demonstrate these to your classroom.
Here's our 3rd and final experiment where we will be testing convective heat transfer. Here we've got 2 blocks of ice and a timer. We will place 1 ice cube on top of the test section, 1 on the interior of the test section, and then turn on the fan. We will then measure the length of time that it takes for the interior ice cube to melt versus the exterior